Hi, welcome everyone to my YouTube channel. My name is Jatin. This is my first YouTube video ever, and in this video we're going to talk about how we can leverage the power of machine learning and Python to predict stock market prices. That seems too good to be true, but let's see how it goes. So in this video, as our sample, we are going to take a look at the Pfizer prices. How will they perform? Then we are going to take the real-time data from Yahoo Finance API. Then we are going to take a look at the things that we require, like the close price, open, volume, and all stuff like that. Then we'll be trying a couple of algorithms on the data to see what performs well, and I have did some background work for you guys already, and I saw that the LSTM model performs best in this case. If you don't know about LSTM, go check out the videos from other channels about the concept of LSTM, or the long short-term memory model. After that, we'll see how does the Pfizer stock perform, and if you want to know it will go up, it will go down, stay till the end of the video. And if you are not interested in any of the details, I'll suggest skip directly to the end of the video and see the prediction for the next 5 or 7 days. I will shift to the code walkthrough now, and we'll see you at the end. Okay, so we are here in my PyCharm window. So I usually like to use PyCharm for all my Python projects, just because the kind of features and flexibility this beautiful IDE gives us. Okay, so first of all, we'll import all the necessary libraries. This is the Y Finance library for importing the data directly from the Yahoo Finance. I'm using Plotly to plot all those graphs, NumPy to do the numerical calculations, pandas. That doesn't need an introduction. Now, the machine learning algorithms that we'll be using, specifically the deep learning ones, we'll be using from the Keras package. Keras internally uses TensorFlow. We'll also see that it uses TensorFlow as a backend. Okay, so I have imported all the libraries now, and after that, here you see I will download the data from the Yahoo Finance API. For this example, we are going with a Pfizer stock, just because due to the current coronavirus condition, healthcare industry should be booming, and Pfizer is one of the main players in the COVID vaccine. Okay, so as you see in this graph, the Pfizer stock price reached a maximum of around 23 in 1999, and after that again broke out in around 2014, around the 2014, early 2014. And after that, since then, if you see a linear graph, it is going up, but down here we see the stock crashed when COVID hit us, and after that it has been going up. But if we consider in the recent times, the last year, you see this is a place when the market crashed. There are numerous factors which can affect the stock prices, but today what we are doing in this video, we're just taking the historical data into account to see what historical data has to offer in terms of prediction for the stock prices, and what can we make out of these historical data. Now, the predictions that we will make today, they will definitely give you a high level picture that where could the market go. So here we make a data frame, so that we do not spoil the original data that we downloaded from Yahoo Finance. We take only the necessary columns, and first of all, I don't like messy code. Control Alt L. That looks much better. Okay. So drop all those unnecessary columns. We'll see the data first. What was the data? So the data that we got from the Yahoo Finance API, it has open, high, low, close, volume driven stock split details from 1990s till the latest date. That's 31st December 2020, and today is 3rd of January, and the market was closed. The market will open on the 4th of January. So yeah, we'll be predicting the price of 4th of January and till for the whole coming week. And after the end of the week, let's see how our predictions hold up in the market. After removing all those unnecessary columns, we see that we are only left with the 4 columns. That's open, high, low, and close. The data that we took, that the data was starting from 1997. We'll be getting the dataset values. Basically, we are converting the data frame into the NumPy array for our future for our further use. We are setting up the training size and test size. As usual, we'll be setting the training size for the 80% data in our dataset, and test size will be the 20%. Then now, in order to send our data to any kind of LSTM model, we need to scale that data. And for scaling that data, what do I mean is, you see this data, the stock price was 6 over here in 1997, and it's around 36 in 2020. So that is a lot of variation in the data, which is not good for any ML model. So we scale the data to be in a similar scale between 0 to 1. And as you can see, now we have the scale data that is between 0 to 1. You see. Then after that, after scaling the data, we will come down to getting the training data from the NumPy array. Now this is a NumPy array, it's not a data frame. As you can see, it's ND array. We got the train data. Now we need to set a time step. Now the time step is this tells us how many days of data we should consider to predict the next days of data. Now if you know the concept of LSTM neural network, you would know why we use these time steps. But if you don't know, I highly recommend you go and check out other videos for LSTM concept, and then come back to this video for the practical implementation. Okay, so we define the time step to be around, let's say, 90 days. We'll see 3 months of data. Then we are splitting up the data in the train and test sets. For that, start from the time step that we have to look for, basically the last 90 days of data. Based on that, we'll split up our training sets. We'll convert those training sets into the NumPy arrays. Now, at this point, the X train and Y train, if we see down here, they are in the form of an ND array. But in order to actually send that data to the LSTM neural network, we need to reshape that data into the form that the network accepts. This is the syntax to reshape that data, which takes your original data source, and that takes your the size of the data, the time step, basically the number of days that you have to look back for, and the number of features that you have in your dataset. Now, we are doing a multivariate price prediction. That means we will be not be just predicting the close price, we'll also be predicting the open, high, low, and close. We'll be predicting 4 kind of prices. That's why we are taking the 4 input variables. So we reshape our data, the X train and Y train. After doing that, we also need the test data set. So we'll be doing the same thing for the test data set. After that, the same thing follows. We'll convert the test data set also into the NP arrays, and we'll reshape that in order to test the predictions on LSTM network. Now, this is the meaty part of the video, I would say. That's the whole place where we start to build our model. Now we start by taking the sequential model, and one by one we continue adding layers to that. Now, first of all, we add an LSTM layer with about 100 neurons in that. I just chose 100 neurons because I am looking at around 3 months of data in the back to calculate the next days. So that's why I took a number around 100. Then we have the return sequences true because we need the outputs from the previous layers to go in the next ones. And for the input shape, we'll have the number of columns and with the number of features that we are feeding in. If you see what are the number over here, so if you see that's xtrain.shape1, which is xtrain, that's our xtrain. 90 is the number of rows, that we have, then the number of features that we have, and that is our input shape for the very first layer in our LSTM model. We move on to the next layer, which will be having the same neurons. Then the third layer, this is kind of our last hidden layer, and this is our output layer, and this will only have the number of features that we are wanting to predict. Okay, now we use a optimizer. Most commonly used optimizer is Adam. I also went with that, and with a learning rate which is also useful in this case, 0.0001, so that we do not want more learning rate over here, else it will just finish the process fast but with very low accuracy, and it will not reach global minima, if you know about global minima. Then here we compile the model and we see the model summary. So that's our whole compiled model. Now we define a bunch of parameters that that the model needs: the epochs, batch size, verbose, and we also define a mechanism for it to stop early, because I do not want it to run for all of the 150 epochs when the same accuracy or the same metrics could be achieved in, let's say, 50 epochs. So we'll define an early stopping mechanism where we monitor the validation loss with a patience of 10 epochs. If it sees the same kind of accuracy and parameters for the last 10 epochs, the thing will stop and we'll have a final model. Here we define the early stopping mechanism, and here we start to fit our model. And now the model training speed will depend on the type of computer that you're using, the type of CPU or GPU that your computer has. Now I am running on TensorFlow CPU version, so it is kind of slow for me, but if you use a good GPU, it can be a lot faster for you also. I will speed up the video and we'll see you when the compilation finishes. Okay, we're back. So that took quite a long. I think that took approximately 2 to 2.5 hours to complete the training. And on epoch number 68, we see our training has been completed. So early stopping clearly worked for us. Okay, now let's see what are the predictions on the test dataset. Here we use the model.predict function to test the predictions on the testing dataset. Then we again do the inverse transform, because in the beginning we did the transform. We did the transform in order to make the data in the format that LSTM accepts. Now we want it to be transformed back into the original type that we had before. So we'll do the inverse transform. Okay, now if you'll see the predictions, see, now we have the predictions in actual dollars and the scalar format, right? We will check the RMSE. Now we'll just check the root mean square error on both the test sets and on the training sets as well. Okay, so we did the RMSE, and the test set RMSE we see is approximately 31.43. Okay, we do the same thing on the training data set also, and the RMSE ideally should be somewhere around the test RMSE in order to get decent results. We'll see what is the RMC on the training data set. Now, keep in mind, it was taking longer time because we had more training data than the testing data. Okay, so it's not very close to the testing set, but it's still close enough. Now, here comes a prediction part. We have our model ready till now. Now here comes the prediction part. So for prediction, we will be making a new data frame which will have only those four columns that we have in our LSTM model. That's open, high, low, and close. We'll make a new data frame which will make a new ND array. This is the numpy array. We'll make a new numpy array which will contain only those values, basically which will contain the last time step days values. That means in our sample, we're considering the last 90 days of sample, so this will have the last 90 days of data. Now um, we'll make a again a numpy array so that we can iterate over the day. We can iterate over the days that we want the result for in the coming loop, and we can store the result into this array print price. Okay, so I made this loop to go over the prices for each day and then add the day's price back to this data frame in order to predict the next day's price. To show an example, let's just get the prices for only 2 days. So I'll run the loop from 1 to 3. That means it'll run the loop for first and second day, and we'll check the day. If the day is not equals to 1, if it's not the first day, we'll come this one in the next iteration. Now let's consider this is the first day. We'll scale the data set again using the scalar transform. Then we will create an empty list. Then we'll append those scale values back to this list and make that list into a numpy array. Then again, reshape that numpy array into the shape that's acceptable by LSTM model. This step is very similar to the steps that we performed above for training the model. And then we use the same method to predict it. And after prediction, this will also be in the form of a numpy array. And to get values from that, we just print out it in a sequential manner. That's open, high, low, and close. Okay, so let's run this loop for 2 days. Let's see. So here we go. Here we got the day 1 predictions. Open 36, close 36.18, open 36.14. Second day, open 36.19 and close 36.27. Now, today at the time of recording this video, it's 3rd January 2021. So these predictions that we are seeing, this is for 4th January and this is for 5th January. Now, these predictions could not be very accurate because this is just based on the historical data that we had available. There are a couple of things that can affect the market. That's why it's so dynamic. We have the news affecting the market, we have other companies affecting the market, we have the competition, there are a lot of stuff. So at all times, I do not suggest anyone to rely completely on these kind of historical predictions. If you are basically, if you are in a market to make these kind of products which will help users to predict the prices, or if you want to make some kind of project for your own which will help you with your investments, stay tuned for upcoming videos. I'm also working on this kind of solution for myself, where I will also take into account the kind of news that's going around the internet and how that news is affecting these prices in real time. Let me know if you guys find this helpful, and also comment down below if you want a code sample for this project. I'll upload it to my GitHub. Just comment down below if you want to see that. So that wraps up this video. If you found any valuable information, please make sure to press that like button and subscribe to my channel. I'll be posting these kind of videos frequently here, and if you have any suggestions or feedback, feel free to comment down below. It will really motivate me to make these kind of videos, and see you in the next one. Till then, stay fit, stay strong.